For our last part on empirical molecular formulas, we're going to take a look at hydrates. Now, hydrates, remember, are compounds that have water loosely attached to it. So we're going to look at a 10.407 gram sample of hydrated barium iodide. So barium iodide is the hydrate. We heat the sample and we get rid of the water, and the dry sample has a mass of 9.520 grams. What is the empirical formula of the hydrate? So the dry sample, meaning that's just the barium iodide, is the 9.520. So we're going to take that 9.520 grams. We have to write our formula properly, which is BAI2, and we're going to go ahead and convert that to moles. So it's moles of BAI2, and the formula weight for that is 391.15 grams BAI2. And when I calculate that, I get 0.0243 moles of BAI2. Now I need to do the same thing for the water. But I have the mass of the hydrate and the mass of the dry sample. I don't have the mass of the water. So in order to find the mass of the water, I need to do a separate calculation. And I'm going to do it up here just because I don't have much space on here. But I'm going to take that 10.407 grams of my hydrate, and I'm going to subtract the 9.520 grams, and I'm going to end up with 0.887 grams of the water that was driven off. Now I can use this down here, 87 grams of H2O, and convert that to moles. And I get 0.0492 moles of H2O. I'm going to divide through by my lowest number, 0.0243, and that's going to be 1, that's going to be 2, and when I write this, it's BAI2 dot 2H2O. Remember, in chemistry that does not mean multiply. That's how we show that it's loosely attached. In fact, it's sort of added on. Let's take a look at another. We have a 1.500 gram sample of hydrated magnesium sulfite. It's heated to drive off the water, and the dry sample has a mass of 0.737. What is the empirical formula of the hydrate? So our dry sample is our magnesium sulfite. So we have 0.737 grams magnesium sulfite, MgSO3. So we have to write our formulas properly or this won't work. So MgSO3, and the formula weight is 104.09 grams MgSO3, and I get 0.00708 moles of MgSO3. And then again, I need to find the mass of water, but I don't have that because that's what was driven off. So I'm going to just again use this space up here, but 1.500 grams of my hydrated compound minus my dry compound. Sorry about that. 0.737 grams is going to give me 0.763 grams of H2O. Now I'm good to use that down here. 0.763 grams of H2O times 1 mole of H2O over 18.02 grams of H2O. And I end up with 0.0423 moles of H2O. I divide through by the 0.00708, 0.00708. That one obviously is 1, and that one is 6. So I have MgSO3 dot 6 H2O. I hope you've gotten both of those examples down. So now we're going to move on to something that's called molecular formula. So empirical formula is what you've been doing, and this is what we've been doing, is the simplest whole number ratio of atoms in a compound. This is different from our molecular formulas. Molecular formulas is the exact formula of a molecule. It may not be the simplest whole number ratio, but a multiple of that ratio. So in fact, the empirical formula times some sort of number gives us the molecular formula. So when we look at this, on the basic level, the molecular weight of benzene, an important industrial solvent, is 78.0 grams, and its empirical formula is CH. What is the molecular formula for benzene? So we know that benzene is somehow CH, but we don't know what multiple of that it is. So what we need to do is we need to find out what the mass is of our empirical formula. So if CH is our empirical formula, I'm just going to take the 12.01 for carbon and the 1.01 for hydrogen, add it together. That's what the empirical formula weighs. How many times does the empirical formula go into the molecular formula? And in that case, it's 6. That means if I have C1H1, which is really what I have when it's CH, my molecular formula is C6H6. See how the empirical formula is the simplest whole number ratio? And the molecular is what it actually is. Let's look at another example. What is the molecular formula for dichloroacetic acid? If the empirical formula is CHOCl and the molar mass of the acid is 129. So again, I need to find out what my empirical formula weighs. So I have to do 12.01 grams for the carbon, plus the 1.01 grams for the hydrogen, plus the 16.00 grams for the oxygen, and 35.45 grams for the Cl. I add those all together. I get 64.47 grams. Well, how many times does that go into 129? It's sort of obvious that it's 2. So I'm going to go ahead and solve it out. And it does, in fact, equal 2. Which means I have to double all of these things. So it's now C2, H2, O2, Cl2. Not too bad. But now we need to combine it with what we've learned the other day. So now we have to find the empirical formula, and then we're going to use it to find the molecular formula. So ascorbic acid, also known as vitamin C, has a percentage composition of 40.9% carbon, 4.58% hydrogen, and 54.5% oxygen. Its molar mass is 176.1 grams. What is the molecular formula? So, just like we did in class, we need to we're going to assume 100 grams, so we have 40.9 grams of carbon. We're going to convert that to moles, 1 mole of carbon over 12.01 grams of carbon, and I get 3.4 moles of carbon. I'm going to take 4.58 grams of hydrogen times 1 mole hydrogen over 1.01 grams of hydrogen, and I'm going to get 4.53 moles of hydrogen. And then 54.5 grams of oxygen times 1 mole of oxygen over 16.00 grams of oxygen equals 3.41 moles of oxygen. Divide by that 3.4, divide by that 3.4, that 3.4. So this equals 1, this equals 1, and this equals 1.33. Now, we need to get this to whole numbers. I know all my work is correct, 1.33. It's not 1.5. The easiest thing for me to do is to turn it into a fraction. This is how I see it best. So I'm going to turn this into 4/3. If I want to get rid of this denominator here, I'm going to need to multiply this by 3. If I multiply that by 3, I need to multiply this by 3 and multiply this by 3. So I end up with a 3/4/3 ratio. That means my empirical formula is C3H4O3. Now, what's my molecular formula? Well, now that's where that molar mass is going to come into play. So I need to figure out what this weighs. So I need to do 12 times 3 plus 4 times 1 plus 16 times 3, and I end up with 88 16.03 grams. I'm going to take my 176.1 grams, divide it by my 88.03 grams, and end up with 2, which means I need to double my whole empirical formula. So it's C6H8O3. This whole part here is what we learned yesterday. We just found empirical formulas. This right here is the new part for today, where we're going to take those empirical formulas and then use them to find molecular formulas. And then we'll look at one more. Aspirin contains 60% carbon, 4.48% hydrogen, and 35.5% oxygen. Its molecular mass is 180. What is the empirical molecular formulas? So again, 60.0 grams of carbon times 1 mole carbon over 12.01 grams of carbon equals 4.99 moles of carbon. I have 4.48 grams of hydrogen, 1 mole of hydrogen, 1.01 grams of hydrogen, and I get 4.99 moles of hydrogen, 35.5 grams of oxygen times 1 mole of oxygen over 16.00 grams of oxygen equals 2.21 moles of oxygen. Divide by 2.21, divide by 2.21, divide by 2.21, and I end up with 2.25, 2.25, and 1. Again, in order to convert this, it's easiest for me to turn it into a fraction. 9 over 4, 9 over 4. That's just still 1. I'm going to multiply this by 4, multiply this by 4, multiply this by 4, and I get a ratio of 9, 9 to 4. So I have C9, H9O4. It says, what are the empirical and the molecular formulas? In order to have known the molecular formula, you would have its molecular mass, here it is 180. Sorry about that. So we need to quick add this up. So I need to figure out what this weighs. So I'm going to do 12 times 9 plus 9 times 1 plus 16 times 4. And I get this to be roughly 181, which means in this case, my empirical and molecular formulas are the same, and that can happen. They can be exactly the same. And that is it for today's notes.